as well. Okay? Okay. Now, what does it mean? Let's say I have a table. What does it mean when I have x 0? What will be my y? 1, right? So on and so forth. And if you plot, you will realize that if you go this way, cutting through 1, and this x-axis is actually the asymptote. Asymptote means what? Will it cut it? No, it will approach it. Understand? Okay, now, then, what if I have y equals to 2 times 3x? What will happen to the graph? It 6. Hold first. I heard the word 6 and I'm uncomfortable with it. I'm allergic. Because when I see this, I think you times then you put x, no? Is it correct? No, Now, look at this second one. It will also be the same shape. But when x is 0, what do I get? It comes at 2, right? So, it will come at 2. Everybody clear? The shape of an exponential graph will always be the same. It's just that it will cut at one point only. Now, then I need to stress one more time. What if I have a negative? It will be reflected about the x-axis, so it will go this way. Am I right? What if this is a negative? Then it will go this way and then it will cut at where? Negative 1. Are we clear? So far, okay? So this is called the exponential graph. Everybody okay? Cannot. So exponential graph. Alright, can you look at page 131 now? All of you look at page 131. Okay, now can you look at the top, figure 5.4. Can you see that it's the one that I have drawn over here? Everybody okay? Now look at the one below. Can you see it's the one that I've drawn over on the right side? Yes or no? Now as I said, I will not be showing the negative one because negative is always reflection about what? The x-axis. Everybody clear now? Okay? Alright, now next. Can we look at example 5? All of you look at example 5 on page 132. All of you look at this example on page 132. Why is it the other way around? Okay, good. Let me just focus this properly so that we can take a look at the question. Why is it so correct? Okay, good. Now, all of you look at the question. Now, this is a very easy question now. Okay? The question says this. Okay. Using a scale of 4 cm to represent 1 unit on the x-axis and 2 cm to represent 1 unit on the y-axis, draw the graph of y equals to 2 power x for x between -1 and 2.5. Use your graph to find the value of y when x is 1.8. So part A. When x is 1.8, what is your y? And part B, the solution of 2x equals to 4.6. These are the two questions that we have. Alright? Okay, now, for a graph that is a curve, you need at least 7 to 8 points. Understand? Not just 2 points. Now, can all of you look at this table? How many points did they use? Page 132. Can you see it's 8 points there? Can you see it? They use 8 points. Now, then I'm going to scale this down. Can you look at this curve here? This is the curve that I will get, right? Can you see it? According to your graph here. Now, can you see you will get this curve? It's a smooth one. Can see? Everybody okay, huh? Now, then the question says this, this is where I'm going. Some people just draw, and never read the question. When x is 1.8, what is y? You must go and look for 1.8, right? Then you dot up, you read here. So what's the answer? 3.1. 3.5. Look at your textbook. Y is 3.5. Can you see? Everybody okay? Can or cannot? Okay, now, it's part B that I'm worried about. Now, can you tell me what's the equation of this curve? Y equals to 2x, right? Now, how to solve this from the axis of a curve? I must add a line, right? Okay, now can you see 2x is already the curve? So what do I add? I add what? Y equals what? Yes, 4.6. Y equals to something is a straight line, right? Correct now? So can you see they're going to look for y equals to 4.6, they draw a line, then they get the intersection, they will get this point. Can you see that? Okay, so the answer from the graph in the textbook is 2.2. Can you see or not? Can you see that the answer for x is 2.2? Yes. Can you see what I'm talking about here? Okay, now, so the question is this. We can also add lines when we see this type, as long as this side is the equation of the curve. Understand? Then you just go and add this line. Okay, but don't say add 4.6, it's add y equals to 4.6. And we must label the line. Is that understood? I don't want people to move everywhere, also talk to everyone. Then you're a loudspeaker. Understand? Okay, you everything, so it's alright. As you talk again, you will call loudspeaker, whatever. Yeah. Okay? Alright. Now, next. Let's take a look at the next page. Page 133. Now remember I told you all this type, you must be able to match the equation. Correct. Why is that so? Because this type of question will come up in E-Maths paper 1. They will ask you to match the correct graphs. Now can you see it's rather easy to match? Everybody clear? Huh? So don't make mistake when you are matching. Follow? Okay? Because when you do algebra, some of you already make a lot of mistakes already. Then even identify a graph also can make mistake, then you have no more marks left. Everybody clear? Okay. So are we clear about the exponential graph? Exponential means 2 to the power of x or whatever the power of x. Everybody clear? Okay. Now next one that I have is this. Gradient of a curve. Now I'm going to tell you what we mean by gradient of a curve. Now everybody look at this graph on the block. This is the curve, right? Remember in A-Maths I told you if I have a line and it touches the curve at one point, this line is called a tangent. Remember? A tangent. Okay, now how to find the gradient of the curve at this point? Now curve changes. Correct. That means the gradient also changes. There's no one specific gradient. Because for a straight line, it's constant. Therefore, I have a constant gradient. But this one, at this point, is like that. Now, let me enlarge it over here. Supposing this is the curve. At this point, this is the tangent, correct? What about at this point? Then, this is the tangent, right? Touch at one point and continue, correct? This gradient will confirm be greater than this gradient because this is deeper. Can see it? So, what do you mean by that? Gradient of a point of a curve, at a point of a curve. That means if let's say I want at this point, draw a tangent here. I want at this point, you draw the tangent there. Then you find the gradient of that particular straight line. That is the gradient of the curve at that point. Understand? Now, then there's one more thing that I need to stress. Can you look below? Here. All of you, look below. Okay? What are they talking talking about right here. Okay, all of you look up. When a line L1 touches the curve at P, L1 is called the tangent to the curve at P. Can you see here? Okay, this is tangent. Okay. Now, similarly, when a line L2 touches the curve at Q, L2 is called the tangent of the curve at Q. Can you see this line here? Correct. Now, how to find the gradient at P? You just draw the line at P, then you go and find two convenient points. Write down the coordinates and use the gradient formula to find the gradient. Is that clear? I say two convenient points, right? Don't choose those points that you cannot read the coordinates. Choose those points that is exactly on the corner of a square that you can read the coordinates. Do you understand? And don't choose very close points like here, very small triangle. No, choose a wider triangle. You'll be more accurate because you can read better. Understand? Okay? Now, then the problem is, how do I know how to draw the correct line? Correct? Now, let me just show you. This is important because some people don't know how to draw tangent. They anyhow draw. Let's say I have this. I want this point. The gradient of the tangent at this point, or the gradient of the curve at this point. Now, you actually should have a ruler that's this long. This will be needed in chapter 9 in your A-Maths also. If you have the whole thing transparent, it's okay. But a metal one will not do because you cannot see the points. Because we need to draw best fit line. Understand? When best fit line is when it's opaque, you cannot see. When it's transparent, then you can adjust. Okay, now everyone look about. When you put the ruler there, it must touch at this point. You can see it. There's the tangent. Now, you do not do like that. Can you see the slant? Can you see it touches more on this side than the point? You say it still passes through the point, but it's not accurate. Do you understand? And what's more, it only can touch the point. If you cross, let me use the other way. Can you see it like that? Wrong already. Why wrong? Because it didn't touch at one point, it touched at 2 points already. Understand? What's worse? People draw like that. Never touch and say don't touch. I think the eye something wrong. You understand what I'm talking about? Huh? So you must know how to adjust your ruler. And some people use pencil that is not sharpened for 20 years. Okay, so your line becomes very thick. Like you want to do some calligraphy like that. Okay, also cannot. Understand? Now, so what's the moral of the story? When you draw the line that is the tangent, all of you look down. You must make sure. Hello? I bring this up especially to show you. You must make sure that it's balanced on both sides. Can you see? Understand? Then you draw. It must touch the point. Can you see? You cannot say, some people very cute one, they draw right, then this is the far right. Oh, they draw already right, there's a gap, no? What they do is that they go and darken it. Then they say, oh, pass through already. Pass through your head. Do you understand? Cannot like that one, okay? Then some people like that. They pass through, but they pass through very likely it's 2 points. You understand? You must also adjust properly. Understand? And one more case. They draw right. They draw like this. Now, do you think it touched that point only? It touched many points. Understand? Now, if it's like very slanted and you cannot touch, you must make sure it's balanced on both sides. Understand? But it must not cut the curve. Understand? It must be a tangent to the curve. Everybody clear? Tangent means only touch at how many points? 1. Okay. Everybody clear now? Everybody clear now? Okay, good. So, you must have a ruler. Okay. Then it comes to some people that I want to remind. That means you must have ruler. You cannot have pencil lead casing to draw your line. And you also cannot use exercise book, the edge there, to draw the line. It will not be a line, understand? It is, I don't know what you call. Okay? Alright, now next. So this is called gradient of a the red one. This one is important. I want you to take note and underline some of the things here. The gradient of the curve at a point is defined as the gradient of the tangent to the curve at that point. Okay, hence the gradient of the curve at P is equal to the gradient of line L1. And the gradient of the curve at Q is equal to the gradient of line L2. Okay? Why is the gradient important? We'll do some more in the next section and also when we're in Sec 4. There are several reasons, but the most important one you should understand for now is that gradient tells us something about the rate of change of one variable with respect to the other. Okay? Now, if the gradient is gradual, the change is small. What if the gradient is very steep? Then the change is large. Do you understand here? Yes or no? So this is very important. I know you've done it in physics already, but I'm reiterating here so that you can understand your physics better. And I will also communicate with Mr. Tuan to say that I have already done it. So if the class still don't know, then the class something wrong, okay? Alright, are we okay here? Okay, next, I'm going to do this part. Everybody look at example 6. I'm going to show you this very quickly. Can you please know, don't, oh my god, here? You, oh my god, also no use because it's in the syllabus, huh? Okay? Now let's take a look. Let's take a look at this particular question. I'm going to write the important one, the important things on the right side. Okay, all of you look at the board now. The variables x and y are connected by the equation blah blah. The table below shows some values of x and y and the corresponding values of y. Now find the value of a and the value of b. That means you're supposed to find what is a and what is b. So this one no problem, right? Just plug in the formula, use a calculator and do it. Okay, if it's not exact, it's to 360. Understand? Then using a scale of 2 cm to represent the zero, okay, draw this graph. Now, then by drawing a tangent, find the gradient of the curve at point 1, 2. So this is part C, huh? Find the gradient of the curve at point 1, 2. Okay, I'm going to do this part C first. Will that be okay? Okay, all of you turn to the next page. Next page. Now, when I draw the curve, it's like that. And everybody look at the ball. Okay? Can you see y-axis, x-axis I draw is like that, right? I'm explaining. Don't want to listen also, never mind. Later you draw wrongly, your problem, okay? Alright, now next. What did the question say? I want to find the gradient of the curve at this point, 1, 2. The saddest thing is you identify the wrong point. Okay, now where's 1, 2? 1, 2 is here, right? Correct. Then you put your ruler. Over here, can you see this particular straight line? All of you look at page, your answer on your textbook. Okay, then I'm going to choose 2 points on the line to find the gradient. Now, I don't use vertical change, horizontal change. I use gradient formula. y2 minus y1 over x2 minus x1. It's faster. Everybody there? Okay, you look at the graph. Can you see that this is a very convenient point to choose? When I know the coordinate of this point. What's this? 2 what? 2 and what? 3 point? 3.5, right? This is 3 point. Here isn't it 3.5? 2 and 3.5, correct? Talking to you? Yes, okay. Then we choose another point. Okay? Now, can you look at this point here? This is what? 0.5 and what? What's here? 1.3. 1.3, yes. Can see? Can see? I'm talking to you. Can see? Okay, now, so what are we going to do about it? So you will say, they want to find the gradient at this point. So you will say, gradient, I will write 3.5 minus 1.3 over 2 minus 0.5. Can see it? I and the margin of error, okay? Alright, so are we clear here? Okay, now then I want to ask a question. I'm adding, listen up. What if I want the gradient of the curve at 4, 2? Where should I draw it? At 4, 2. At this point, right? Then I must put the ruler here, right, and draw a straight line, right? Then I identify 2 points, right? Okay, but by slanting this way, the gradient is already negative. You must know. So if you apply that gradient formula and it gives you positive, that means something is wrong. Do you understand what I'm talking about? So we have to be very alert. Are you clear? Are you clear here? Okay, no problem with drawing the tangent. Okay, good. Now, next point that they ask. Can we look at part D? Can all of you look at part D? Okay? Now I'm going very slowly here. Alright? Let's look at the question. And don't talk over there. I can hear noise. Now look at this question, part B. The gradient of the curve at a point HK is 0. What kind of line will have gradient 0? Very good. I saw the shape you have pointed. It's like that, right? This one gradient is 0, right? Okay. Draw the tangent at point HK and hence find the value of HK. This one is the easiest. Okay, can you all look at the graph that they gave you? Look at the graph that they gave you. Can you see that at every point on the curve, they will have a slant? Only at the maximum point, the tangent is 0, correct? This will be the tangent, only tangent that's horizontal. Other than that, all the tangents are slanted lines. Can you see? Okay, all of you look at this is important. If you have a maximum point, this tangent has gradient 0. If you have a minimum point, this tangent is also 0. So it depends on whether you have a maximum curve or minimum curve. Everybody clear? So this one, the gradient is confirmed 0 already. And what point is that? 2.1. 2.5, and just now you calculated this is an exact answer. All of you refer to the table. What's the exact answer to this? 2.5 and 3.125. Understand? I told you already, the table, if it's exact, you must give exact. If it's not exact, then you give it to 3 centimeter figure. 3.125 is exact, because there's no more extra. Understand? Extra, there's no places. Okay, this is actually 318. Can you see? It's a rational number. Everybody clear with what I'm saying? Can or cannot? Everybody okay until here? Everybody perfectly clear? Okay, very good. Now, so what have I done today? Oh, listen to me, What I've done is that I've done exponential curve. The gradient of the curve at that point, you must draw a tangent. Then you use the gradient formula to find the gradient of the tangent. And you choose 2 convenient points. Don't anyhow choose the points. Understand? Because it will affect your answer greatly. Everybody clear? Now, a more gradual line will have a smaller tangent, smaller gradient, and it is the change will be smaller, right? A steeper line, the change means the change is bigger. Everybody clear? This one we'll do this in the next section when we do sketch of a container in different shape and the height, how it changes. Okay? Alright, now, can you tell me what's the number on your content page? Now, what's the number on your content page? Now, now write 18. Now write 19. Okay, very good. Can you all write 19? Today's date. Forms of exponential functions. on the board. Okay, 4 questions on the board. You must do these 4 questions. At least draw the curve and come back tomorrow so that I can add the lines. When I say draw the curve, you don't just plug in the point and do nothing wrong. You must join up the curve. Just like when you eat something, right? You don't have to tell your body must digest. The body must be able to digest. If you need to instruct the body to digest, I think all of you will be bloated to death. Because some people will always forget to tell the body to digest. Understand? You just eat whatever you want. Okay? Alright, now, first question. 1 round paper, 1 question. First question, number 3. Can you write this at the back of the graph paper? Now, hold on first, don't do first. Can all of you listen to me? I'll give you 1 minute to copy down later. All of you look at page 137, everybody. 137. Look at question number 3. Aaron, are you ready? The table below shows some values of x and the corresponding value of y corrected to 1 decimal place. Find the value of a and b. Now, part 2 give you the scale, am I right? So I'm going to tell you what's the scale, and then after that, part 3 and so on. Okay? Tomorrow, when you come for lesson, at least the curve should be drawn. Is that clear? Then I add the rest for you. If you still want to solve, you'll fly out the class. Want to laugh, right? Fly with an exponential curve. You fly to the sky. Okay, with the ground as the asymptote. You'll never reach the ground. Okay? Alright, so number 3, skill given, everything okay, huh? Okay, next question number 1 for you. First question. Number 2. Oh, you're very lucky. It's not 4 questions, it's only 3.
Yes.
Yes. Hey, very hey. Number 7. Using a scale of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis, draw the graph of this. Okay, this one the table not given. Everybody must draw this table. Number 7. So people are very sad, huh? Don't be sad, no? I'm sad, not so many rubbish. Because your graph is never nice, no? It's a rubbish graph. Okay? I see the word entered in, I know it's rubbish already. But do you know that I have to carry this rubbish home? Put it inside my room and mark furiously the rubbish. Okay? And you see, must tell you the comments, where after I write the comments, nobody even bother to read the comments. It's self-doubt, don't know right what. Let her write and waste the red ink. Okay? So, this self-doubt is like that, right? There's nothing I can do to help you, okay? Okay, fill this up and draw the curve for me. Will that be okay? The scale is given already, so I don't have to bother. Later on, the rest of the lesson, I'll let you draw, don't worry. Okay? But tomorrow, if you tell me you haven't drawn, there's something is wrong with you. You don't understand instructions. Then you got to go for English remedial. Or you want me to speak in Hokkien? Yes? Yes. I don't know whether you understand what I'm saying. Okay? I can give Hokkien. I'm the HOD of the Hokkien department. Okay, I'm the principal of the Hokkien University. Okay, now next question. Okay? Question number 8. Yes, right? The one another way. I want this way. Understand? Can I? Okay. Draw the graph of blah blah. Okay, so let's see what's the blah blah like. Table not given, so I'm going to give you the table. Okay. This one must be more points, if not you will get a very funny curve. Okay. -2, -1.5, -1, -0.5, 0, 0.5, 1, 1.5, 2, 2.53. Okay? Now I say already, if it's not exact, you give me 3 significant figures. If the have no answer, now can you look at the number 0? All of you look at the number 0, excuse me. Hello? If it's 0, this is 1, right? Okay. If it's 0, this is 1, or if it's 0? 1 over 0 is what? Don't come and tell me error. What is it called? Undefined, right? That means you will have the y-axis as the asymptote. This one got no answer one. Understand? Understand? Clear or not clear? Don't get over and join, huh? Understand? What? I say this one got no value. Do you agree? Then must you join to the y-axis? You draw first, then let me know more. If you join, then tomorrow I will join you with the detention club also. Okay? Alright. Let me give a few instructions before I start tomorrow lesson, and let you do the work now. I want these 3 graphs plotted. I think I better don't put like that. Then if people think it's X, then I really cry to myself. Dash, dash. Okay? Because I put cross, they think it's X. I put something else, they don't know what they are doing. Huh?